Have you ever looked up at the sky on a clear day and wondered, why is it blue? It's a question that has puzzled humans for centuries. The answer lies in a fascinating interplay of light, air, and our own eyes. Every day we walk beneath this vast azure expanse. It's so common that we often take it for granted. But the sky is a marvel of nature, a canvas that changes with the time of day and the whims of weather. From the pale blue of a summer afternoon to the deep indigo of twilight, the sky is constantly shifting. The sky's blue color is not just beautiful, it's also crucial for life on Earth. This blue tint helps regulate our planet's temperature. It reflects some of the sun's energy back into space, keeping us from overheating. So why blue? Why not green or red or purple? The answer involves a journey. To understand why the sky is blue, we first need to talk about sunlight. The sun doesn't just produce one color of light, it actually emits all the colors of the rainbow. These colors travel together in a beam of white light. Each color has a different wavelength. Red light has the longest wavelength, while violet has the shortest. When sunlight enters Earth's atmosphere, it encounters tiny particles. These particles are much smaller than the wavelength of visible light. They include molecules of nitrogen and oxygen, which make up most of our air. Blue light gets scattered more than other colors because it has a shorter wavelength. As a result, blue light bounces around the atmosphere more, reaching our eyes from all directions. Our atmosphere acts like a giant filter for sunlight. It's not just empty space between us and outer space. It's a complex mixture of gases, water vapor, and tiny particles. This atmospheric soup plays a crucial role in creating our blue sky. The atmosphere is densest near the Earth's surface. It becomes thinner as you go up. This means that light has to travel through more air particles when the sun is low in the sky. That's why the sky can appear more red or orange at sunrise and sunset. The blue light gets scattered away before it reaches our eyes. But during most of the day, when the sun is high, sunlight travels through less atmosphere. This allows more blue light to reach our eyes from all directions. Our atmosphere also protects us from harmful ultraviolet radiation. The scattering of light by air molecules is known as Rayleigh scattering. It's named after the British physicist Lord Rayleigh, who first described it in the 1870s. This process is like a cosmic game of pinball. Light photons bounce off air molecules in all directions. Rayleigh scattering doesn't just happen with visible light. It also occurs with radio waves and other forms of electromagnetic radiation. But it's most noticeable with visible light because that's what our eyes can detect. The blue sky is a perfect example of Rayleigh scattering in action. Interestingly, if we could see ultraviolet light, the sky would look even more colorful to us. Many insects, like bees, can see ultraviolet light. So, to sum it up, the sky looks blue because of how sunlight interacts with our atmosphere. Blue light gets scattered more than other colors. It bounces around in the atmosphere and reaches our eyes from all directions. This creates the illusion of a blue dome above us. But the blue sky is more than just an optical illusion. It's a reminder of the complex and beautiful world we live in. Every time we look up, we're seeing evidence of the sun's power, the atmosphere's protection, and the fascinating properties of light. The blue sky also tells us about the health of our planet. Changes in the sky's color can indicate pollution or other atmospheric changes. While we focused on why the sky is blue, it's worth noting that the sky isn't always blue. The color can change depending on various factors. At sunrise and sunset, for example, the sky often turns spectacular shades of red, orange, and pink. This happens because sunlight has to travel through more atmosphere when the sun is low on the horizon. During these times, most of the blue light gets scattered away before it reaches our eyes. The red and orange light, with their longer wavelengths, can pass through more easily. This creates the beautiful warm colors we associate with dawn and dusk. Weather conditions can also affect the sky's color. Clouds, of course, can make the sky appear white or gray. But even on clear days, humidity and air pollution can change how light scatters in the atmosphere.